Hello and welcome to Lecture 1. This is going to be a lecture on the principles of global infectious diseases. We're focusing primarily on the infectious diseases of the developing world. However, a lot of the times the diseases of the developed world and the developing world can overlap. Just keep that in mind. But for the purposes of this course, we'll focus primarily on the developing world. Some of the objectives of this lecture will include to define the infectious diseases and understand their impact on the mortality and morbidity worldwide. List briefly and describe the major types of agents that can cause infectious diseases, describe the host agent environmental triangle, and describe the types of epidemics. Understand the basic measures of epidemics. Basically what I want you to do is to understand the different definitions that we're going to be using throughout the course. So let's get right into them. Some of the definitions include, the first one you need to understand is, as this is the name of the course, is what an infectious disease is. An infectious disease is a communicable disease that can cause an illness to a specific pathogen or an infectious agent. It can be the agent itself, but it can also be a toxic compound that is made by the agent. For an example of that would be to look at like a tetanus toxin. Tetanus toxin itself is not part of the tetanus bacteria, but the bacteria produces it. So that's an agent within that's being produced by the bacteria. Communicable diseases or infectious diseases can be transmitted from person to person, from animal to person, from animal to animal, from animal to environment, from human to environment, and so on. It can also be transmitted through the environment, specifically through the air, water, food are the main causes, but not exclusive. If you look at a historical comparison and a future comparison of what are the infectious diseases that are going to be major throughout the world, this is again throughout the world, not necessarily the developing world only. You can see that the major diseases still, in 2004 up to 2030, will always be ischemic heart disease. And this is as a percentage of death in relation to all of the other diseases. However, infectious diseases are not that much far behind, starting with the lower respiratory infections, the pulmonary infections, diarrheal, HIV, TB, and so on. And you can see that even though by 2030 a lot of these infectious diseases will be lowered on their significance according to WHO, they'll still actually have a high relative rate of death compared to some of other diseases. If you look at the top 10 developing world diseases, infectious diseases, you can see that lower respiratory infections, HIV, malaria, and diarrhea top off the top 4. And they actually represent a huge chunk of it, and they end up getting a lot of funding for research comparative to other diseases. We'll get into some of those details a little bit later. To understand infectious diseases, you need to understand how the cycle of infectious diseases work and what's called the epidemiological triad. Basically, the epidemiological triad consists of a host, an agent, and an environment. And each of them, the host being the person that's infected or the animal that's infected, the agent is the actual infectious agent, and the environmental factors that are related to those all have impacts on the nature of the infection itself. The hosts themselves have the ability to make the infection, someone sick, and be transmitted from person to person or from animal to person. There's a lot of different factors that actually have to do with that. Genetic susceptibility, your age, children in general, and extremely old people tend to be more susceptible to disease. The amount of immunity you have. Many of these diseases are not major diseases unless you're, say, immunocompromised. For instance, HIV isn't necessarily a disease that will kill you, but will make your immune system very weak, and you may be more susceptible to other diseases, infectious diseases that healthy people would not be susceptible to. And the level of resistance. Some people have a higher level of resistance. This may be genetic, it may be environmental, and there's different levels why that happens. And then health-related characteristics, like, as I mentioned, immunosuppression with HIV or transplant patients, but also things like pregnancy can be another aspect to that. The agents themselves we're going to talk about each of these different groups in some more detail, but just some examples include bacteria, viruses, protozoa, and helminths. And we'll talk about the examples as the lectures go on. The environment also plays a major factor. There's a wide variety of environmental factors that makes it more or less possible for agents to reach the host. The physical environment, the amount of rainfall, the temperature, For instance, tropical climates tend to have a lot more diseases, whether it's cause or effect. The poverty levels in developing countries tend to be more in the tropics. There's a lot of debate that we can discuss about that, and I look forward to seeing your responses on the discussion board related to that. Speaking of the discussion board, if any of you would like to comment on any of the slides in this lecture, feel free on the discussion board and we can bring it up. The social environment, the amount of knowledge people have is also a major impact. Health education is often at a lack, even in the developing world. In the developed world, health education is often subpar, I'll say. But housing characteristics is another aspect. Floors, are they dirt floors? Are they insulated windows? Do you have screening so that mosquitoes can't come in? And then movement of people is another issue. There's a lot of refugee situations. There's a lot of work transport. And all of these issues, people can transmit diseases, move diseases to new areas, and so on. There's a lot of terminology and definitions in this. We'll go into some of these. For each of these, I kind of want you just to understand what they are, and so when you see them throughout the lectures, you'll know what they are. They may come up on the exam at the end as the definition, so just be aware of what they are and how to define them. And then we're going to go over some of these, if not all of them, throughout the course, but also I'll give you a little bit of a definition in the coming slides. Let's talk about first infection. Infection is the entry. It's basically the starting point of an infection, of a disease within a person. It's the entry or development and multiplication of the infectious agent in the body of the man or animal. Human or animal, I should say. I always say man, I'm sorry. I should change that to human. Political correctness. Moving on. An infection agent does not always cause the illness. You may have what's called a subclinical dose, in which case a lot of people, might get sick, and then some people who get infected might not get sick, and those people tend to get subclinical infections that don't actually cause an illness. There's several levels of infection, and they include the colonization. So you'll have colonization of Staph aureus, for instance, in the skin. It's normal flora that can be there. It does not cause an infection, but if you get a disease that has the ability to cause infection but does not, you get what's called the subclinical. You can also get a latent infection. One of these examples of this is herpes simplex. Another example could be something like HIV, as it's basically hibernating in your body over the years before it becomes an overt infection again. And then you get a manifest or clinical infection, and this is something that tends to be more often the acute infections, the colds, the flus, things like that, but doesn't necessarily need to be. A manifest or clinical infection can be a latent infection that reactivates, for instance. Contamination is the presence of an infectious agent on the body or surface or on the clothes, bedding, toys, etc., that is not supposed to be there. It can be on the food, it can be in the water, and that's typically how you'll get infected, through these different fomites or the water and food itself. Infestation is the lodgement or development and reproduction of arthropods on the surface of the body, on the clothing. For example, the mites or lice. The term can also be used to describe the invasion of the gut of a parasitic worm, such as roundworm or whipworm, and so on. The contagious disease is the disease that's caused by the particular agent. Some examples include scabies, trachoma, STD, or leprosy. The disease, the actual infectious agent, sometimes will have the same name and sometimes will not. STD can be a wide variety. Leprosy is called by leprosy bacteria. Trachoma is called by a bacteria, and so on. The host is the person or animal that actually gets infected. They would not be infected under normal conditions, and this can include an obligate host, which is the definitive or primary host, or an intermediate host that is basically a host that could be subclinical and transported to other people, and it could be someone that does get infected but and gets disease, but at a sub level. The vector of infection is a carrier. They don't necessarily get the same type of infection and the same type of disease states. They are typically insects, but not necessarily. And they can transport the infectious agent from species to species. And that's the major way, for instance, malaria is transported, is from mosquitoes to humans. But they can also infect other animals, other mammals, for instance, and transport the disease that way. Those mammals or animals may not get the same clinical features, but they can have a clinical infection. A reservoir is that type of animal. It's a person or animal which the infectious agent normally lives and multiplies, but which does not necessarily cause a disease in that animal. It's the natural habitat of the infectious agent as well. The incidence or prevalence, this is a key characteristic to understand when you're talking about more of the global health aspects of it rather than the clinical aspects. We're going to be using these terms quite often, so I think it's necessary to get a clear understanding of what they are. The incidence of an infectious disease is the number of new cases in a given time period expressed as a percentage infected per year. It's the cumulative incidence for that year. It's also the number per person time of observation and incidence density. Prevalence, on the other hand, is the number of cases in a given time exposed to a percentage of a given time. So prevalence is the total number of people infected at a given time, while incidence is the new number of infections, put it simply that way. An epidemic is the next thing that you need to understand, and these are all now terms that are more the public health end of it. An epidemic is an unusual occurrence in the community of a disease specific to the health-related behavior or other health-related events clearly in excess of the expected occurrence. So if you're expecting, say, 10,000 cases of polio per year in a country that has the disease still there, if you end up getting like 100,000 cases, it's a huge spike in what you expect, and that's what an epidemic basically represents. And there's several types of epidemics. You can get, and these are very classic cases. For instance, in food poisoning, you might get a primary case where the disease will take 11 days to onset, and that primary person might then expose other individuals to a case in which they all will then get it another 11 days following that time period. So you can see this double, small little spike at 11 days and then this huge increase afterward. Another type of epidemic is basically a common source or continuous outbreak. And this can be an example of water that's contaminated, continuously contaminated. And so people are getting continuously infected. It's not one individual that spread it to others, but rather the water that's contaminated. So multiple people are drinking this water throughout the time period. And then you can also get these intermittent type of infections, and tuberculosis is a good example of this, where it may be, you'll see this as a seasonal type of epidemic as well. If you have a particular disease like that, like influenza, that can cause various seasonal epidemics. But for instance, TB here, the contact spreads it to other contacts, and then they spread it to other contacts. So you can actually see over time the number of cases is increasing as time goes on. And then you get these, as I mentioned, these are more the seasonal type of things where you kind of get that similar pattern. It can be multiple days where one person would infect another 5 people, and then those 5 people can infect 5 other people, and so on. And you get this huge spike until the season is done, in which case at that time the virus tends to burn itself out. Endemic, on the other hand, is when there's a disease present within a community that's usually expected at a particular frequency within that population. So an endemic disease might be, for instance, a parasite disease in a developing country with the extreme poor. You expect them, because they don't have access to sanitation and clean water, that they'll have a certain number of parasites in their body, and that tends to be more of an endemic situation. Hyperendemic and holoendemic. The term hyperendemic expresses that the disease is constantly present at a high incidence or prevalence rate and affects all ages. So it's a slightly different than just a generic endemic, where it's kind of this low level. In a hyperendemic, you get these, I would almost call them hotspots that are native to that area. A good example of that would be, for instance, river blindness, onchocerciasis. In areas where there's a high bite rate of the black flies, you might actually get a certain number of hyperendemic spots close to the riverside where the black flies bite and spread the disease. Holoendemic expresses a high level of infection beginning early in life and affecting most of the child population, leading to a state of equilibrium such as the adult population. So there's many examples of that as well. Pandemic and exotic. So pandemic is when it a epidemic spreads beyond the borders of the endemic region. So you get this spike, say, of influenza. A great example of a pandemic would have been the 1917 Spanish flu that went around the world and basically killed millions of people throughout the world. Pandemics tend to be the ones that scare a lot of people. Ebola could have been a pandemic if it wasn't controlled. Exotic diseases are those which are imported into a country which they do not usually observe. Rabies in the UK, for instance, you don't really see rabies anymore as an outbreak. Another example might be if you had a case of malaria in the United States. Malaria does not exist in the United States, so now if you have a case, it's usually an imported or an exotic case. And then you get sporadic outbreaks. These tend to be more scattered. They tend to be low level. You'll get, polio infection, for areas that haven't been vaccinated. Another example in more recent history is, if you've all remember just reading about it, you got the sporadic outbreak of measles from people that went to Disneyland in California. And so that's a sporadic outbreak in the sporadic disease. Attack rates in primary and secondary cases. So attack rate is a proportion of non-immune exposed individuals who become clinically ill. So these are people that have basically not been either immunized against a particular disease, or that they are immune, they've never been exposed to the disease as a wild type. So they are the first line. And then you have the primary and secondary cases. Primary cases are the people who come into and infects the population are the primary people. Those are the secondary ones, are the ones that actually get it from the primary cases. Very simple as the definition stands. Zoonosis, epizoic, and enzoic. So zoonosis is an infection that's transmitted under normal circumstances by vertebrate animals to man. Such examples include rabies, from, say, for instance, from a bat biting a human, plague, bovine tuberculosis, and so on. Plague is a zoonosis because the mice or rats can spread it. However, it actually comes from the fleas that are biting the mice and rats, and then they jump onto the human. An epizoic is an outbreak of a animal disease, and an enzoic is an endemic area occurring with the animals, for instance, bovine TB. Nosocomial infections, very simply, we're not going to focus too much on this because, again, unfortunately, there isn't a huge amount of nosocomial infections I should say fortunately there's not a lot, but unfortunately because there's not a lot of hospitals, there's not a lot of nosocomial infections in the developing world. Basically, nosocomial infections are hospital-acquired infections. People are often immunocompromised in some way. They may be sick with something else, so if they're ill to start with, they are more susceptible to getting other diseases that have a high rate in these particular hospital areas. An example of some major examples of nosocomial infections in the developing world what we could discuss would be Ebola, for instance. Most of the people that developed Ebola were actually people that were in the hospital already for other reasons. A lot of the healthcare staff got infected because of the patients in the hospital, and those are considered nosocomial infections. Opportunistic infections are very simply diseases that do not affect people who are generally healthy. They typically affect people that are immunocompromised in some way. The best examples for the global, developing world would be HIV. People who develop nosocomial infections such as tuberculosis or CMV typically have HIV, for instance, and because they would have been able to fight off the disease a little bit easier, the HIV made it much more difficult, and that's why it's an opportunistic infection. So eradication and elimination. We're going to have a whole discussion on eradication and elimination programs, but just to give you an idea, so elimination is when you actually can reduce the amount of disease to almost zero within a given area. Eradication, on the other hand, is when you actually reduce the amount of disease to zero, completely zero throughout the world. It's basically removing that disease from the planet. One example of that is smallpox. The reproductive rate of infection. So the reproductive rate of infection is the potential for an infectious agent to spread. Influential factors include the probability of transmission between an infected and susceptible individual, the frequency of population contact, duration of the infection, the virulence of the organism, and the population's immune proportion. Basically, the reproductive rate is the ability and the speed at which an infection can travel from person to person. The dynamics of disease that being able to switch from person to person, the chain of infection, is you have the source. The source can be environmental, it can be a vector, it can be so on. Then you have the mode, so how does it actually transmit? Is it through the skin? Is it respiratory? Is it urogenital, and so on? And then from there it can move to the susceptible host. So that's basically the dynamics of transmission, the chain of infection. The source of the reservoir is as I mentioned before, it's where the actual disease comes from. Is it a person? Is it an animal? Is it a substance? There's all kinds of different things that it can be, and different diseases have different things, and we'll talk about some of the different reservoirs in further discussions. As I mentioned before, the reservoirs can be human, animal, or non-living reservoirs. Human reservoirs have a pretty complex combination of different ways that they can do it. The human reservoir can have a clinical infection, so a person with flu, for instance, that is actively coughing can spread the disease. They can have a subclinical infection where they actually spread the disease. One example of that would be Typhoid Mary. If you all have a chance to read about her, if you know about her, is a very interesting story about how she was spreading typhoid through the areas of New York in the early 1900s, or it was the late 1800s, early 1900s, and she had subclinical, was a carrier of the disease, but didn't have actually infections, so she was able to spread it to different people. But then also other issues such as the carriers. What is the portal way of entry? What is the way of exit of the disease from person to person? The case is defined as the person in the population that's having the particular disease or disorder and is under the investigation of that disease. Carriers are people that can have the disease, have the infection, but not necessarily the disease. And then animal reservoirs, as we discussed, can be the zoonosis. They can include everything from your pet that can spread disease. Cats can spread disease in kitty litter. Cryptosporidium is an example of that, and so on. But it can be everything, and the mosquitoes are, sorry, not mosquitoes, but rather the cattle that mosquitoes bite can be a reservoir, and so on. Soil is also another major reservoir. Water can be a major reservoir. And the mode of transmission is often through drinking the water, or through walking on soil with small cuts in your skin and your feet, eating contaminated foods. You can touch unclean objects. There's many different ways that you can get these transmission of the disease. And then a susceptible host is the person that's actually getting the disease. There's 4 stages that are required for successful parasitism, for instance. The susceptible host is typically deals more with the concept of parasites, and this is the way of entry, the site of election inside the body, the portal of exit, and the survival in the external environment. So when you're talking about a susceptible host, the host is typically dealing with more of a parasite theory of something that's going to live in the body for a long time and causes problems to the person that's infected, but also has its own life cycle within the body. Virulence and other case fatality rate are another 2 definitions I'd like you to know. Virulence is the degree at which the pathogenity of the typically viruses, but not necessarily, of the microorganism in general can actually cause disease. So virulence is the amount of particles, for instance, the amount of virus particles or the amount of bacteria necessary to actually cause an infection. For instance, the virulence of hepatitis B is 100 times higher than HIV. You need 100 times more HIV viruses than HBV to be able to cause infection. And in the case fatality rate, fairly self-explanatory. The rate at which people would die from an infectious disease is over a given time. Serial interval or infectious period. So the serial interval is the gap between time between the onset of the primary and secondary cases. It's the interval between the receipt of infection and the maximal infectivity of the host. It's also called the generation time. So how long does it take, again, from it to travel from one person to the other person? The infectious period is the length of time a person can transmit the disease. It is effectively For the Ebola, they were always talking about the 28 days. So that's the infectious period, is how long can the person, from the time that they're infected to the time that their body actually is able to clear the disease, can they spread the disease from person to person. The incubation and latent periods. The incubation period is the time from exposure to the time of the development of disease. Pretty simple. And then the latent period is the time of exposure to the onset of infectiousness. So after you've actually been exposed to the disease, how long are you actually infectious? And that's pretty much it for the lectures for this introduction lecture. I know it's a lot of definitions, but I just wanted to go through it fairly quickly. Again, you can look through it on your own time. I read mostly from the slides, I know. I'll try not to do that so often, but this is just definitions, and I needed you to get an idea as to what the different discussions were going to be, that we're going to have. In the coming lectures, we're going to talk about the control of infectious diseases, and then we're actually going to start to really get into the meat of the individual diseases, which is actually where I find it a lot more enjoyable. I hope this was a good lecture, and I'm looking forward to seeing your responses on the first discussion, which I shall post immediately after I post this. Again, thank you again, and have a good week.